Good afternoon, everyone. This is Patrick Sun from the National Operations Center of Excellence. We're just going to get an extra minute or so for a few more people to log on, and then we'll get the webinar started. So just hang tight. All right, everyone. Once again, this is Patrick Sun. We're right about 2:01, so I think it's definitely worth for us to get started, and I want to thank everyone for joining us on this webinar. Today's webinar is on learning about operational SPaT deployments, and so it's actually webinar number 9 within our SPaT Challenge webinar series that we've been doing for a while. And the webinar will include presentations from several agencies that have operational SPaT deployments, and they'll put an emphasis on lessons learned and discussion that we can have that encompasses all stages from planning, procurement, installation, testing, and operations. And so as a reminder, the National Operations Center of Excellence is designed to offer resources and support for the transportation systems management and operations community. Feel free to browse the entire collection of our NOCO resources in our Knowledge Center and subscribe on our website for our newsletter and major TSMO announcements. There's links that are available for you in the useful links box on the right side of your screen. And just a reminder, for this and every webinar, we have a recorded version of the webinar along with the presentation slides that will be available within 24 to 48 hours in our on-demand learning section of our website. And then we'll also have a question and answer session at the end of the webinar. So if you have any questions, we encourage all of you to enter them in the questions pane at any time. And we'll read out loud the questions one at a time, and our presenters will answer accordingly. All of the participant lines have been muted, and so please just submit everything in the chat window and the Q&A section. For today, our agenda that we have is we're going to have Blaine Leonard give us some introduction and updates about what's been going on with the SPaT Challenge. And then we're going to hear from Maud Aslami from North Carolina DOT and Alan Davis from Georgia DOT. And we'll be able to have an extended Q&A session at the end of the webinar. And with that, I'll hand it over to Blaine to start us off on the webinar. Blaine?
Thank you, Patrick. Appreciate that. Welcome, everyone, and thanks for joining us today on this webinar. As I'm sure everyone is aware, the SPaT Challenge is a challenge that challenges all of us, state and local infrastructure owners, to deploy DSRC infrastructure and broadcast SPaT and MAP in at least one corridor or network in every state of about 20 intersections by 2020. So the little logo, 20 intersections in 50 states by 2020. We've made a lot of progress in the 2.5 years since we got started. We now have about 39 locations in 26 states. You can see the latest version of this map on the Operations Center website. The blue pins represent those states, those locations that have an operating system that are actively broadcasting, and the green pins represent all of the rest of us who are still working on getting ours up and going and planning. So it's exciting to see the growth that's going on in the in the process. We have over 500 RSUs operating in these locations and about another 2,400 or so planned in the rest of the pins over the next year or so. And so we're excited. You can go on the map, of course, and click on those individual pins and find out information about that particular installation and who to contact to get a little more information. We're anxious to hear from those of you who aren't represented on the map by a pin, and you can go on the SPaT Challenge website here on the Transportation Operations site, and the link is shown there. And click on this location where I've got the blue arrow, and that will help you tell us what you're up to. And we would encourage you to do that. As Patrick indicated, we've had 8 webinars to date over the course of this year, and all of them are available on the SPaT Challenge website, recordings of the full webinar or individual speakers, so you can look at individual topics plus their presentations. We started back in March with some introductory materials and systems engineering and concept of operation. We went into some design considerations, talked about SPaT messages, and agency experience doing that. We spent a couple of webinars dealing with how to create the map message. Got some information from a couple of states and from the US DOT on a map creator tool that they've produced. We talked about specifications for the RSUs, roadside equipment and backhaul, licensing the devices. We had a bunch of topics on our 6th one in June, showing some deployments in a couple of places and talking about SCMS, Security Credential Management, and I'll talk about that a little bit more in a minute. We then had some operational deployments from 3 locations on our July webinar that talked about those, and our most recent webinar in August showed us another couple of another location in Pennsylvania, and then talked about what some people are finding as a next step, and that is deploying OBUs in vehicles. So you can go to the resources page or the SPaT Challenge page and get access to all of these recordings. If you look at the blue arrow at the very bottom of the page here, oops, I've backed up I've gone forward too fast. That will take you to the locations where the webinars are recorded. If you go up to the next blue bar, it'll lead you to a link to a place where you can download a verification document. We've had a website about how to verify our broadcasts to make sure they're working. And then the top left corner arrow takes you to the resources page, which shows you, and I've gone the wrong direction here, shows you all of the different resources that are on the SPaT Challenge page, which you can link to and download to help you with your deployment. And here's a list of those. We have another webinar coming up in January where we will again talk about operational SPaT deployments and give some examples. So stay tuned for that one and put that one on your calendar. As I indicated earlier, the SPaT Challenge, the basis of the SPaT Challenge is really to broadcast the SPaT and map message using DSRC technologies. As you've noticed through the webinars we've had over the past year, we've had a lot of other topics that we have topics, of course, that deal directly with SPaT and map messages, but we've had other topics that deal with other things. Broadcasting a security certificate, broadcasting a correction message for the GPS, installing OBUs in vehicles, and implementing V2I applications. Those are not intrinsically part of the SPaT Challenge, but those are places where a lot of SPaT deployers have gone as a next step to investigate some of those things. And in both of the presentations you'll see today, you'll notice that they've done some of those kinds of things. And so we've talked about those so that people have an idea of what to do next. And a lot of agencies have found they wanted to do more than just the basic SPaT Challenge approach. So we've tried to present some of that information. Wanted to mention the SCMS, the Security Credential Management System. I won't go into detail about what it is, but in essence, it is the element that establishes trust in our broadcasts. If you look at webinar 6, there was a detailed presentation on what it is and how it works, and you'll see this fairly simplified architecture design here in that presentation. It talks about how all the broadcasts that will be made someday will have security certificates attached to them, which secures that message and lets the receiver know that it's hasn't been tampered with and it's a secure message. It's much like what you and I find when we go on the website and use our credit card to purchase something. Those transactions have a security credential attached to them, and that's how we come to trust them. In Webinar 6, it was recommended by the speaker, Steve Novostad, that we all think about implementing security certificates sooner rather than later. So I just wanted to give you a little bit of an update on what's going on in that world just in the last little while. The U.S. DOT led the creation of an SCMS proof of concept system to support the 3 CV pilots in Tampa, New York, and Wyoming. But the proof of concept system they developed really wasn't suitable to scale up for national deployment for you and I to use. It didn't have misbehavior detection. It didn't have an overall policy framework. It wasn't built to be large enough. And so although at one point I think a lot of us felt like that was the system we would be able to try to jump into and use, that's really not the case. So the FHWA has recently held some workshops. Maybe some of you on the call today were at one of those workshops where they started to develop some strategies for deploying a full-scale system. They looked at governance and oversight and high-level policies, roles and responsibilities of the various entities that would be involved, and business and financial models. How does it get paid for? Where do the charges go? And all of that. And it was an in-depth, detailed look at how the system might work. The outcome from that will lead FHWA to continue down the path and help in the development of a full-scale SCMS system, more than likely to be developed by the private sector with some federal involvement or oversight. But I think the message is that a national SCMS system is not imminent. It's not going to come about in the next year or two, most likely. And so the current landscape is that the pilots are using a private certificate provider. Cadillac, which has DSRC devices on one of its models, has a certificate system that they've built for their models specifically to secure their V2V transactions. And some agencies around the country are exploring certificates through some private providers, and there are a few providers out there that you can get security certificates from. I think the key here is that's possible. That's something you can choose to do. These are available solutions, but they're not the same as a complete national SCMS system. They don't have all of the elements. Misbehavior detection, for instance, is not something that you get through the private security provider. So this is a piece that's in transition. There's been some activity around this in the last few months, and so I just thought I would raise the issue and put it out there. Many of you may know these things, but I just thought it would be helpful to understand that and where we are. Finally, one other thing before we get into the full presentations. As I'm sure many or all of you know, the US DOT recently issued version 3.0 of their automated vehicle guidance document. Several things are interesting in this document. I don't know how many of you have read it, but I'll just point out 3 or 4 things that I noticed in the document. First of all, it increases the focus beyond just light passenger vehicles to other modes, freight and transit and some other things. And so there's discussion about how these technologies might work in those areas. It reiterates, and here's where this is relevant to what we're talking about with the SPaT challenge, it reiterates that connectivity, both vehicle to vehicle and vehicle to everything else, infrastructure included, is a complementary technology that will enhance automation. It's not mandatory. Automation can happen without it, but it's a complementary technology, and they sort of encourage its use for the benefit it brings along. The document mentions the SPaT challenge as one of the things that has caused a broader deployment of V2I technologies, and there's a paragraph in there about that. And the US DOT encourages the continued deployment and use of the 5.9 gigahertz spectrum. They don't promote any specific technology, but as we know today, the only thing that legally uses the 5.9 gigahertz technology that you and I can buy is DSRC. But they encourage the continued use of that and are supportive of the kinds of things we're doing. So I just thought I would point those out from the document. So with that, I will turn the time over to Alan Davis with the Georgia DOT, who will talk about the very progressive deployment they've got going on in Georgia. Alan?
Thanks, William. Can y'all hear me all right?
Yes.
All right. Thanks for having me. Happy to share about our experiences with our response to the SPaT challenge, kind of the things we ran into and what our plans are for the future in looking at this and where this is all taking us. Again, I'm Alan Davis with Georgia DOT, our Assistant State Traffic Engineer. So I want to kind of take back a little tail back here, trip back to memory lane about how we kind of got on this path. And it started back around 2014 when we had internal discussions about whether we as an agency would pursue trying to be a pilot site when those solicitations were going around. And we realized at that time that we just had too many gaps in our infrastructure and architecture in terms of operations, that it wasn't a good time for us to pursue that. So we kind of tabled this effort and sat down about a year later and worked through some strategic planning, came up with some ideas about where we wanted to be, where we felt we needed to be as an agency within the connected and autonomous vehicle space, and put some things on paper and had some ideas. Shortly after about that time, the SPaT challenge came about, and since we'd already been thinking about this space and wanted to be in it, we quickly realized how important it was for us to be a participant in that. So we jumped on board as an agency and developed these kind of primary goals you see here about what we wanted to do with the SPaT challenge for us as an agency, not just in answering the challenge, but also where does this get us, what does this do for us, what does it take Georgia as a state in terms of transportation. So primary goal from that was to figure out how this connected space would need to work with us. How does it work for us? What network components, infrastructure pieces, and business process we had to do to support broad applications in the connected vehicle area. And on a secondary level, we wanted to deploy roadside units and equip vehicles with OBUs to be able to demonstrate and facilitate this technology. Really wanted to focus in kind of four major areas. Safety and mobility are the obvious touch points. Freight is a big thing in Georgia, so we always look for opportunities that we can improve and leverage our freight resources in Georgia. We have one of the busiest ports in the U.S. in Savannah, so it's obviously something that's always, as a DOT, it's always on the forefront of our mind. And we also wanted to pursue partnerships in this space to have a good idea of where we could work with others, work with the private sector, work with academia to touch all these spaces that we were trying to get into and leverage this technology to improve things that we were working on. So fast forward a little bit, one thing I would point out is in between that planning, the SPaT challenge and all this, that Georgia passed legislation to allow autonomous vehicles and truck platooning in Georgia. And then shortly after that, we kicked off our pilot deployment as that was our official response to the SPaT challenge. So we identified 54 intersections on 2 corridors that we were going to target for SPaT and MAP messages. We did these strategically based on the types of corridors that these were, the kind of different topography they dealt with. One is a pretty urban, pedestrian focused, lots of traffic, all kinds of things going on kind of corridor. And another one goes through a very dense urban area with lots of tall buildings and bad GPS line of sight. And then another part of that same corridor is coming into town off the interstate, so it's a nice commuter stretch. So we had a lot of different characteristics that we could work with and play with and had good infrastructure in place to work with it. We also identified 12 ramp meters that we were going to place roadside units at, primarily for utilizing the amount of traffic that would be on the interstates that they were adjacent to for testing out basic safety message reception and broadcasting traveler information messages. That's a piece we have not completed yet, so I won't focus too much on that, but it's something on our radar. The ramp meters, of course, were selected because we had a solid network connection there and infrastructure to be able to easily deploy a roadside unit. We really targeted 4 applications that we look at that I'll talk a little bit more later on, but it was a red light warning, basically alerting you that you were not going to clear the intersection or were approaching a red light based on your trajectory. Pedestrian signalized crosswalk. Basically the idea here was to provide an alert to a vehicle that there was an activation of a pedestrian in an adjacent sidewalk. Nothing fancy beyond that, no automated detection or anything like that, but literally if there was a button pushed, that an alert would appear within the vehicle. Phase termination, next signal phase, kind of your basic SPaT message of this much time until the light turns green or red or yellow. And then your green band speed, which is an idea we played around with, that basically would display the minimum speed a vehicle would need to drive in order to clear the next intersection at green. So that's what we targeted, and this is something that we started with a turnkey deployment with, we put out as advertisement. Atkins was the prime on that to help us deliver it, with Southwest Research as a technical resource on that program. And those 54 intersections turned on and went live in June 2018. Kind of a look at our approach of how we structure this within our system. So SPaT challenge, we're focusing in on the signal timing messages here. We have a ATC signal controller in the field that it was at the time, quote unquote, ready for connected vehicles. And of course, after a few software updates here and there and an additional application, we were able to get there. So the controller there is spitting out the NTCIP messages, and that CD app you see there is actually a software application that is residing on the controller itself, the driver signal controller. It's not a separate box or piece of equipment that's needed, but it's like an app on your phone that is running. So I think it's kind of a unique and cool approach that we were able to leverage based on the infrastructure that we already had in place. So then that CD app then packages up the J2735 message out to the radio, which then passes it along to the vehicle over DSRC. One big component of what we were pursuing was to be able to have this open data approach as well. So we get calls, I'm sure a lot of other agencies do, from folks wanting to install some equipment on their network that sniffs out NTCIP messages or signal phase data to package up and broadcast out to repackaging algorithms that can sell back to various car manufacturers like Audi and BMW, so on and so forth. And we're happy to work with a lot of those folks as much as we can. We feel like we have infrastructure data that's important to get out to the public. We just have a lot of issues and concerns of plugging this device in, plugging this device in, plugging this device into our network, and how can we have any security or insurance of security with having those multiple devices plugged in on our network. So we decided the best approach for that was just take our data and provide it to the world through this open data approach. So we have a separate application that runs and connects back to each one of our signal controllers to aggregate that data and provide a data stream, and we're hoping to have it up and running and live here in the next month or so. One unique thing, too, about this approach that I think we have of having this application that resides in the controller is that, in theory, of course, this is a theoretical concept because it's, well, software manufacturers that are providing these things. So they say they can do a lot of things, and then it takes a little while to actually prove it. Forgive my cynicism there, but in theory, there's a lot of built-in integration and seamless application between the connected vehicle piece and the signal controller. So we have a working theory that we'll be able to do and handle things like signal priority through that application without having to introduce any additional equipment into the equation of this, that it's already something that there's a seamless integration between the DSRC, the CV app, and the ATC signal controller, that those functions can be exploited fairly seamlessly. But that's something that's on the whiteboard to figure out later on and test out. Just another look at our approach here visually. We envision, there will be intersections we have that have no DSRC radio roadside unit installed, and we do have some that are. And so we have a mixed medium of vehicles that are out there, as well as some that are not connected. Of course, they don't get any information from the infrastructure. And then you may have a cellular connected vehicle that you see there in the middle of the screen that is able to have, lots of vehicles these days have LTE connections built in, and I think that's one of the selling points of the Audi platform as well. We wanted to be able to utilize those resources, like I said, and so we aggregate that data and stream it out to the third-party service that's able to deliver it back. And of course, there's latency associated with that, but it's still a valuable asset, we feel like, for some of the infrastructure messaging that we can get out. And of course, the DSRC vehicle with the no latency approach is able to directly connect to the infrastructure. So a multifaceted approach that we hope will carry us a long way in terms of how technology evolves and what is down the future, down the road in the future. A quick look at the applications we were having. I mentioned the pedestrian and crosswalk one specifically. I will say that is not one that we have working yet. It's a challenge we have in this, and that, that's an undefined object in the DSRC connected vehicle world. Pedestrian push-button activation is something that does not exist on any kind of OBU as a standard. So we're kind of playing around with that and figuring out what we're going to do with it. Do we just write a custom script or something to simulate this as a proof of demonstration? Do we kind of leave it be? We see value in providing that information of pedestrian and crosswalk or any kind of pedestrian application to any kind of these connected vehicle applications. So it's something we want to keep on the radar and explore, but just something to highlight that it's not functional yet, and it's it's not something that's probably going to be demonstrated anytime soon. In Atlanta, on top of our 54 intersections, the city of Atlanta themselves deployed about 22 intersections of DSRC Radio 2 about the same time that we were. And separate deployment took a different approach in terms of how they integrated into their system and got it deployed in the field. And I'll talk a little bit about how that looked during our validation and testing, having our system on one arterial and literally a block over, we had the city of Atlanta's deployment and what that looked like for us. But again, I want to reemphasize that our approach is, we have this valuable information. In this context, this is infrastructure information about the real-time signal phasing and timing information. And we strongly feel that having that data broadcast, there's folks out there that can aggregate that data and use it and data analytics and improve efficiency, especially when we get back to the freight and logistics side of things. What that can mean, that's infrastructure information that those folks have not had before. And we strongly believe that that can really enhance their operations. So a quick look at what our deployment looked like. On the left there you can see the radio up on a pole. We strapped it to an AASHTO bracket for easy maintenance. In the middle of the screen there you see one of our OBUs that we use for testing, validation, and on the top right there you see our original HMI. That's the Lear product that's out of the box, their HMI system. And on the bottom there you see what the user interface for our what resides on the controller, what that user interface looks like. One thing I want to point out though is as we were going through this, a lot of our applications we were developing were not compatible just yet for the Lear products, and the Lear HMI and the OBU were not on the most current standards and what we were looking at. So we figured out we needed to do something different. So we worked with our partners at Southwest Research to swap those things out for another product. Here you see a Coda Wireless OBU in here. Now I'm not endorsing one product over the other. It's just that that's what we had applications ready to go for in the amount of time we wanted to devote to this. So wrote all our applications on the Coda OBU, and there on the right you can see the application that Southwest Research put together for us as an HMI. That's a screenshot of the tablets we had on our card. That was what we used for our validation and verification the system was running to demonstrate the applications I mentioned before. GDOT certainly doesn't want to be in the app business. We don't want to charge 99 cents or anything to this and put it on the App Store or anything like that, but it was a useful tool in validation. One thing I want to mention here too about our application here that we were using is you see where I highlighted that generic RSU UDP. Southwest Research, as you know, is located in San Antonio, and our deployment is located in Atlanta, Georgia. So in order for the Southwest Research guys to be able to test and validate and work on these applications for us, it didn't make a lot of sense for them to have to travel to Atlanta every time they needed to get data from the field about how these things were operating and what they were broadcasting. So we were able to leverage our applications to create this data stream that could be received directly to Southwest Research in San Antonio, and they could replicate it in the field and test and validate what they were seeing and doing all the way out in San Antonio from here in Atlanta. I just think that's an incredible application of the technology to be able to utilize this on the internet side of things. So just want to highlight how I thought that was interesting. Here's a look at what our application interface looked like here and point out a couple things. You see on the left your phase service time remaining in the signal head. That particular approach that you see right there had multiple movements associated with it, the permissive left turn as well as the through and forward. You see the intersection name that showed up. That's populated from a local table on the tablet and the app, but based on what the intersection ID is. This minimum speed required to clear green. So you see it's highlighted there, a target speed of 10 miles per hour. That is calculating that target speed based on the green band that the controller is spitting out through the DSRC and the minimum time the termination. And based on your trajectory, it's calculating on the OVU whether what speed you need to go to be able to hit that intersection, cross that stop bar before it turns red. So a really cool application, I think, as a guy with a lot of signal history and background. I thought that was pretty fascinating. And of course, your vehicle speed is highlighted there, and all the way on the right there in that tiny text is all the debug information that we used to be able to see what the current state of everything was and how that looked. Another shot here of what the red light warning. This is another application too where it calculates from a trajectory that you're going to hit a red light. It would pop up that big red ball and alert you to it. Validation and testing. This is an important part of our deployment that we worked with Southwest Research to do. We wanted to ensure that what we were broadcasting and the information we had present was in fact true and accurate and what it was meant to be. And here's just a list of all the things that Southwest Research was looking for when they did this. And a lot of this was done through this remote validation as well as recording data as they were driving through that they were receiving from the RSUs. All the way from the properly formatted J2735 compliant messages. That's an important one too, because I mentioned the adjacent corridor through another deployment that was next to ours. While we were out there doing this, the Southwest Research guys would drive that corridor and record it and do some validation as there. And even two adjacent deployments deployed at about the same time, you could see that, of course, ours was the correct and proper one, according to the guys doing the validation and testing that we were paying. But next door you had a message set that was not properly formatted compliant messages. So it's just fascinating that two corridors deployed about the same time, adjacent to one another, were having different information being broadcast. So just to emphasize that validation and testing, to get that ground truth that this is good information is incredibly important with all these deployments. There are a lot of off-the-shelf products out there that say they can do X, Y, and Z with connected vehicles, and it's really important for agencies out there to ensure that the data, the messaging that's being broadcast there is actually true, accurate, up to code, up to standard for what it's supposed to be. Some challenges we had with our project, device interoperability. I know I've heard Blaine Leonard speak of this quite a bit. I mentioned that we had to switch between the Lyra OBU and the CODA OBU because applications are written a certain way for a certain code on the CODA wireless OBU, and it didn't translate directly to the Lyra OBU, and we have to go through this effort to be able to port that from one OBU to another. Does that controller talk directly to the RSU, or do headers have to be reformatted? Is it in binary, or is it in ASCII? All these things were well beyond my understanding and comprehension of coding and knowledge. I just know that it takes a lot of work to get A to work with B, to work with C, to work with A. That interoperability is a big challenge. It's still a big challenge, and I hope that as these deployments proliferate, that's something that gets worked through and sorted out. Map message creation and validation, that was probably, as we'll see in a minute, where we spend a lot of our time is not only in map messaging, but that validation and troubleshooting of all this data is crucial. Most of our expense, most of our effort has been on creation and validation of map messaging and GPS correction efforts. Protected permissive left turns, we had an issue with that within our particular application on our software controllers. It's currently set up to where it only recognizes the arrow. So when you introduce this permissive element to a left turn, it's looking for a red arrow, which means a yellow arrow or a green arrow, which are all protective movements. But as soon as you introduce this permissive movement, it doesn't really know what to do because it's seeing both a red arrow and a flashing yellow arrow. So some software confusion there that we have to get worked out, but initially that was a problem and something we've isolated and been able to work out. I mentioned ramp meters, how we are deploying there. But there's not really any defined objects for ramp meters at this time. I mean, I guess there's a green ball and a red ball, but what does that mean, and what is it going to look like when you deploy it within a connected vehicle system like this for SPaT messaging? Blaine mentioned security credentialing earlier. We early on discussed SCMS of whether or not we were going to attempt it with this, and we realized that it was a bit too much for us to chew on for our initial 54 intersection deployment, especially when we had complete control over the broadcast and the reception of the data that was going to be used here. So it's not something we initially pursued, but we put an asterisk next to us in our ConOps as something we definitely needed to figure out as soon as we started to explore these partnerships. And again, a limited fleet that we ran into. We only have 50 OBUs as part of this pilot that we outfitted. So, and we're in the process of outfitting those. And so that's not a lot of users of the system, but it's something that we hope that will continue to grow. So I want to talk just very briefly on my final few minutes here about where we're going from here. We very early on hoped that this project would be successful and that it would be something that we could make scalable to the rest of the state. So for this type of application, we needed to have, we really felt like we needed to have 3 components at an intersection to make this work. You need to have communications at the intersection for remote management. We needed to have, okay, we've got that in most places. 90% of, or 100% of what GDOT operates and maintains has communications to it. We need to have an ATC signal controller that could handle the SPaT messaging. We have a scalable infrastructure for that. We have these ATC signal controllers all over the state at most locations. Okay, check. So the only piece we're missing here is this DSRC radio. And so combine those 3 things and we see that broad deployment potential in Georgia, that this is something that could quickly scale out to a lot of different places. So over the next few years, we have targeted to deploy at over 1,700 intersections in Metro Atlanta. This fits right into a regional traffic operations program that we have here in Metro Atlanta that is active management of arterials. And so we already have a lot of effort and infrastructure invested into these locations. So adding on this DSRC and the work that goes with it to us is similar to deploying another ITS device with a little bit extra. So we're going to scale up what we have done already on our SPaT challenge corridors to the rest of the city. And the idea we really approach here is that, okay, we can deploy this at 54 intersections. And if we go to somebody and say, you know, your average citizen say, hey, this technology is present on these 2 roads in Metro Atlanta. What do you think about that? It's like, oh, well, that's interesting. It's cool to see it. But then when you approach the subject and say, well, what if you had this technology, this information, this connectivity on every major highway in the Metro Atlanta area? And that's where we feel like we really start to see those light bulbs go off in terms of application potential and use of this technology. And you know, we certainly want to see it proliferate as an agency for the benefit that we'll get out of it and the benefit we see that the traveling public will get out of it. So we're going to put our foot forward and aggressively, Blaine mentioned progressively earlier, that our deployment plans were, I think it's aggressive is the proper adjective here. We'll see if we can pull it off. But already in the works, we have the first 250 of that 1,700 that we plan to have installed by the end of 2018. Just to look here, the blue lines there represent where those corridors will be. And again, our objective here is connectivity on every major arterial in Metro Atlanta and have that open data stream at all these locations as well. So hopefully by the end of the year, that's where it will be. I will mention that a big challenge for us is getting the physical RSUs delivered and to us to be installed. That's been our biggest challenge, is finding the supply for the equipment so far. So fingers crossed on that moving forward. We hope to have it completed again by the end of June 2020. One final thing about that of what that deployment itself will cost. We broke it out into 2 years, kind of identifying, you know, the front load of it will be a little bit lighter to kind of get things moving and hopefully get the equipment inventory. And then the second year of it, they're being more aggressive with almost double the amount of deployments we will have out. So hopefully it will be a well-oiled machine by that point. But $7 million based on our contract prices that we have. I want to mention there, the RSU and deployment is about $2,100, and the other half of everything that we're running into is the configuration and support of the roadside unit. So again, that map message creation, troubleshooting, and all that fun stuff is a big part of what it takes to get these things operational and working. So here's what it costs to do 1,700 intersections in Georgia with an RSU, about $7 million. Again, I'll leave it at that. If you have any questions, there is my information, and I want to hand things over now to North Carolina DOT for their presentation.
Thank you, Alan. Good afternoon, everybody. Good afternoon, all the participants. Thank you for being here and listening to what we have done. So our deployment started just with the SPaT challenge. We didn't have a statewide program yet. We just wanted to learn about the CV technology out there, get our feet wet, and learn in the process. So we started with selecting a corridor that had less impact in terms of hardware and software upgrade. Town of Cary, where we selected the corridor to be to deploy the technology, had a central software system provided by Econolite Centrax. All the intersections were connected to the traffic management center through a Ethernet fiber optic network. The software that we were running at the time was AAC3, again, Econolite product. Also, this corridor, it parallels the Triangle Expressway, which is designated proving ground for connected vehicle technology. So that was another reason why we selected this particular corridor. 20 intersections, 16 intersections along NC55, and 4 intersections off of NC55 on iHouse Road. This is the overview of every intersection in this project. This is the High House Road, where we have 4 intersections equipped with the CV technology. The next 3 slides here basically list every intersection that is in this particular project equipped with DSRC radios. I'm not going to go over each one of those, but those are listed for your information. So basically, again, we wanted to have the least impact in terms of design work and in terms of hardware. So we already have Econolite equipment. So we wanted to go ahead and select a vendor or a contractor that was familiar with what the intersection equipment were and what needed to be done. So we awarded the project as a sole source to Econolite in July 2017. Initially, part of our RFQ was to use Savari RSU and OBUs for this project. And we were anticipating this project to be completed in 19 weeks. And it was a turnkey project. Since we were just beginning to learn about connected vehicle technology, we wanted to minimize the load on our staff and maximize that on the contractor. So they would teach us, what we needed to do and learn from the process. The payment type was not a lump sum. It was itemized. Basically, the itemization had to be the RSUs, the OBUs, integration, testing, training, and installation. So our project total cost was about $506,000. That translated to $25,000 plus per site, per intersection. So the existing infrastructure, as I said, was NEMA TS2 cabinets with 2070E controllers and the Econolite AAC3 software. The system was interconnected through a Ethernet fiber optic network, And the central software at the Traffic Management Center was Syntrax 2.1, I believe, at this point. What we needed to upgrade was to upgrade the 2070E controllers with the 2070C or Linux. So we had to redesign the intersections with a AAC3 Linux platform ready for connected vehicle and high-resolution data. The additional equipment that we had to install obviously were RSUs and the Econolite connected vehicle coprocessor, POE injector, surge suppressor, cabling, equipment, mounting hardware, and also we had scoped 5 OBUs for validation and verification of the system. So prior to going live and install equipment in the intersections, we wanted to set up a test site to make sure the equipment that we have selected, the software and everything works properly. So we set up a test location within our DOT facility. We installed the equipment, created the map messages, the SPaT messages, and verified that everything works. So basically we proved the concept, and after that we went ahead and installed all the RSUs in the 20 intersections that we had identified. Unfortunately, we ran into some problems with the Savari RSUs. They missed delivery times. There was problem with the units themselves. Then the unit had to be sent back for firmware upgrade. Technical support was not really available. I think their engineering department was in India, and the sales department was in here in North America. So whenever we needed to get technical support, that presented a challenge because of the time zone and the difference in the night and day. So there was a lot of issues with getting technical support. So based on those challenges, we decided to reboot and restart the process, and considered to go with an evaluation process where we invited multiple vendors to install their equipment and gave us a chance to evaluate the performance, their technical support, and so on. So we could select equipment that are more user-friendly, and the technical support was more readily available. So we issued invitation to 6 different vendors, Siemens, CAPS, TrafficCast, Lear, Applied Information, and Savari. Again, we wanted to give another chance to Savari to see if being in the competition will make any difference in terms of providing technical support. In the evaluation process, we invited multiple agencies to take part. Obviously, NCDOT was a main player. Town of Cary, where they own the signals. Econolite, our contractors, and City of Concord, North Carolina, also participated because they also wanted to participate in SPaT challenge deployment. Some of the evaluation criteria that we wanted to look at was obviously functionality, available applications, interoperability, documentation, ease of installation, configuration, over-the-air firmware updates, map development tools, support, and the unit itself, the form factor, and how easy or hard it would be to install. So based on those evaluation criteria, we ranked the different units as CAPS came number 1, Siemens number 2, Lear 3, traffic cast for Applied Information 5 and Savari 6. Again, we didn't get a lot of support from Savari, so they ranked really low. Applied Information was not a DSRC technology, they are 4G technology. So obviously we did not consider them for this project. And we went with number 1 and 3, and we again did not select Siemens, although they ranked number 2. That was because they did not offer at the time an OBU for validation and verification purposes. So the new RSUs from CAPS and Lear were ordered in May of 2018, expecting delivery in July, or late June, early July. We completed the installation in late July. We completed the training in August, and the system has been operational since July of 2017. So here is the some of the images that we have from the installation. So we received 2 different OBUs, one from Lear and one from eTrans Dunlaw, which is partnered with CAPS. And also part of this OBU system was an HMI, basically a Samsung tablet equipped with the applications. Here are some of the images from our verification and testing. You can see we have the red light violation warning application implemented. We have the flashing yellow arrow demonstration here. And obviously you can see the red light and the time that is left in each phase as shown here, 22 seconds, for example, here, 16 seconds, and the flashing yellow, 2 seconds left. And so over here you can see that the red light violation warning is a predictive, although the phase right now is green, but based on the speed and the trajectory, the application predicts that if we go to the speed and the time remain, that we might be violating the red. This is the Dunlaw OBU, and with eTrans applications, again, some of the applications that we have implemented is work zone warning, red light violation, school zone, it's not shown here, curb speed warning, and speed limit warning. I don't have images for those, but those are some of the applications that we have implemented. The lessons that we learned from this deployment is obviously to start the FCC application early in the process. It takes a long time and it takes a lot of efforts to procure the different licenses, the geographic and the site licenses. Again, since this was a turnkey project, we did not write a whole lot of a specification. We didn't have a lot of functional requirements in our RFQ, so the next phase of our projects would be to make sure that we have written detailed functional requirements and start with multiple products and not just select one, just because the products out there, and to our experience, they're not very mature, so they still need growing and testing and evaluation. Requiring comprehensive testing and training, again, if the purpose and the intention is to become expert in the field, that we would need to get a lot of training from the contractor so we can maintain and operate the system efficiently. Documentation, again, is a must, and being hands-on is also something that we wanted to make sure in the future be a part of that. We required a co-processor as part of this project. So basically the co-processor was to do the translation between the NTCIP objects and and J2735, but through the project we learned that the coprocessor were not needed because the translation actually happened inside the RSUs. Lead time for equipment is long. I think in our case was 8 to 12 weeks. Some of the problems that we ran into as the system were up and running, we had a problem and we needed to replace one, and it took us a long time to get a replacement part. So that's something that we learned, that as part of the future projects that we specify or include additional spare parts in order to make sure the system continues to operate. I think another thing we learned that there was some equipment were built based on a previous 2009 specification and some were based on 2016. So we wanted to make sure that our project requirements in the future will be consistent on the standard that we will require. In map creation, that was another big challenge. Although our contractor created the map using Google Earth Pro and then a translation from the KML files to XML file in order to upload those files to the RSU. So that was a big challenge. And an easier way to do this and an easier tool to do this obviously would be a plus. So again, to summarize, the challenges is to expect delays. That's part of the process based on, again, the time it takes to get the licenses for the locations, equipment lead time, and there obviously could be weather elements involved. Other challenges that we had with the technical support, so that's another thing to expect during this process. And applications and the hardware, again, is in our experience needs maturity. So to keep expectations not very high, I think that's part of our learning process here and what we learned. When we installed the radios, we installed the existing signal poles were metal, and we did not have an electrical insulation between the RSU risers and the signal pole. During the hurricane here, I think we had a loose power cable that touched the signal pole and basically fried all of our equipment on that particular installation. So obviously for us to go to move on future projects is to consider electrical isolation between RSU risers and the signal poles if they are of metal type. Again, like we started this project with just meeting the SPaT challenge, but we are in the process of developing a statewide policy for deployment of connected vehicle technology in the future. We will be expanding this particular corridor to another 18 intersections to have DSRC radios from vendors that are not currently installed. So basically, we have CAPS and Lear, and we want to go down the list that I presented earlier from the other vendors that we ranked and evaluated, so we can get a feel for the other products and applications. As part of our process and the new signal system projects that we will be working on, we are programming into those projects to identify additional intersections and corridors that make sense for CV technology to be deployed and include that as part of the projects. And also, even if we are not including CV technology in the new projects, we wanted to make sure that the signal equipment that are being upgraded or installed or ready for connected vehicle technology. And in our case, we have a statewide license for Econolite AAC3 software. We have a version that is OS9 based and a version that's Linux based. And the Linux based is the one ready for the CV technology. So we wanted to make sure that our new signal projects considers the software and the hardware that is ready for CV deployment in the future, even if we are not deploying it within that project. With that, that's all we have done currently in North Carolina. As I said, we are in the process of developing a policy for CV technology deployment statewide. We continue to learn, and we have learned a lot from this process, this challenge, and we are hoping to further our knowledge in the area and develop the in-house expertise in the staff to be able to operate, maintain, and deploy additional technology. In addition to this DSRC, we also have 7 intersections that were not part of the SPaT challenge, but they were equipped with 4G technology to also gain some insight and some knowledge into how the 4G technology compares to the DSRC in terms of SPaT message broadcasting. With that, I thank you for your time and be happy to answer any questions that I may be able to.
Great. Thank you so much for both Maud and Alan that presented, and of course, Blaine in the beginning. There were a couple of questions that came in during the webinar, so I think we'll go ahead and ask that. The first question from Nadare Moini is asking, actually this one, each person, each presenter probably can answer. What kind of intersections control mode is in place where SPaT is deployed? Is it time of day, actuated, or adaptive? Let me just go kind of in order. Alan, would you be able to answer that first?
Yeah, all of the locations we had deployed are actuated time of day. And the city of Atlanta corridor adjacent to us is actually adaptive.
Oh, excellent. Blaine, you've got an operational deployment too. I think it'd be worth hearing your answer to that also.
We do. We've got one operational and one about to be operational, and they're actuated.
Great. And Maud, what about you guys?
Our system in town of Cary is a coordinated system. You know,
and it's actuated, of course.
Timing
right?
is managed by the Centrex software.
Okay. Great.
So Patrick, this is Blaine. I'd be curious if anybody on the line, and they could chat in if they know of this, if anyone knows of a location where DSRC SPaT messaging has been deployed that uses an adaptive system. I get that question once in a while, and I'm just curious if anybody that's listening knows of a SPaT challenge location where they're using adaptive signals. They could just type that in.
Yeah.
Thank you.
I have actually come across that question also. Ellen, you mentioned City of Atlanta. If you could just type it in and let us know if they are operational or if they're just still in progress, that'd be great. And we can see if there's some lessons learned out of that that might be interesting for a lot of others. So if anyone knows the answer or if anyone is aware, please type it in. And thank you for kind of the extra information. Let me go to the next question. It comes from Lee Smith, and it was a question directed to Maud. Was your deployment installed with internal DOT forces or contracted out? And what involvement or assistance did you need from consultants and contractors or vendors?
Like I mentioned in my presentation, so our project was a turnkey project. So basically, we required our contractor to do all the work, the design, the procurement of equipment, the installation. Obviously, our town of Cary traffic management and traffic engineering staff helped with the networking side of the system. They opened up the VPN for the contractor to provide the communication from RSUs back to the web application for ETRAN, in assigning IP addresses and providing the VLAN for the RSUs and all of that. We didn't have a consultant in this project, but mainly the town of Cary IT folks helped with the networking side, and the contractor installed all the equipment.
Thank you so much, Mo. The next question comes from Yamilet Diaz, and I really hope I'm getting these names right, everyone, so apologies if I didn't. But Alan, the question is directed to you. Could you explain and expand a little bit more the issues you mentioned with the pedestrian and crosswalk application?
Yeah, so, and I will do it to the best of my ability because it gets a little technical. But, when a pedestrian button is pushed at a traffic signal, that sends a signal to a traffic signal cabinet that the controller interprets, and there's an NTCIP object associated with that, and that's all in that universe. It's understood, and everybody knows what it is. But there's no standard object that I know of within the SAE standards that says, and something that would go to an OBU that says that this message means that a push button has been pushed, and it means to do A, B, and C. There's no standard available for that, so whatever message would have to be created for that, or then that would be proprietary and not something that's universal. So it would only work on our system or somebody who had deployed, the code or application that we had developed. So that was essentially the challenge that was there, is that something had to be defined, and it wouldn't be standard. Not impossible, it's just that it's outside the current standards as far as I understand them.
Great. I think as a feedback, Alan, we'll probably have to take what you guys have developed and at least push it back through to some of the standards development groups and just make sure they're aware of it, and maybe they build off of it, for future applications. So that's great. I do want to thank you, Alan, you and Ken, letting us know about the two deployments for adaptive that are broadcasting SPaT. And Blaine, I think both you and I, we could probably work offline to explore this a little bit more, and perhaps just see where they are, where Ann Arbor and Atlanta is, and how they got it running and operational. And we'll see if there's some resources we could pull out from that.
I think that makes sense, yeah.
Yeah. Those were some of the questions that came in from the audience, and if you have more, that'd be great. We prepared a couple of extra questions that we were going to ask the presenters, and so this one, any one of you can answer. But from what you see, and as your deployment continues or even expands, do you foresee continually using your internal resources to maintain both the hardware equipment and also possibly some of the software that's being needed to be developed? Or are you looking at outsourcing a little bit more just based on the plans that you have set forward? I think, Mo, do you mind if we start with you?
Yeah, no problem. So like I mentioned, I'm sorry here. We currently don't have the expertise to maintain, to operate, excuse me, to configure the devices. So I apologize for my. So one of the challenges for us is obviously to develop the skill set necessary to maintain these equipments. As is right now, we don't have the staff and the expertise to really address the challenges that are we facing with these type of deployments. So we are hoping to be able to, through these deployments, to acquire the skill sets needed for the continued operation and maintenance of these equipment. But right now, we are lacking that expertise. Apologize.
No, that's fine. Blaine, what about you?
So we have used an outside consultant to this point, somebody who does our system integration generally in our system, and they've done the deployment and they've done the software work and they've done what maintenance we've had to do so far. We haven't made this step yet, but we intend to move some of that in-house eventually. We have, a really robust, good, talented set of folks who maintain and operate our signal systems and also our ATMS systems and network, including our HOV tolling systems. And so we have talked about ultimately needing to train them and get them up to speed so they can do some or all of that maintenance as time goes forward. We're not there yet, but that's sort of the long-term plan from what we can see.
Great, thank you. Alan, how are you guys approaching this particular question?
Yeah, so at GDOT, there's probably maybe 3 or 4 of us that know anything about connected vehicles within our agency, so we're pretty thin on expertise internally, so we definitely will in the future continue to rely on outside resources, especially as a lot of the stuff continues to evolve. But like Blaine, we're kind of at a point of making a decision about, are we going to stand up some internal resources to probably support this even further, or continue to rely on that external help. And I think we're probably leaning more towards that. We need some internal resources that are a lot deeper into this as time goes on and as the technology evolves.
And another question that we were wondering, and I guess besides the pedestrian objects and the data objects that we didn't have, but the question actually for the presenters, and Alan maybe you can start, is what was another big surprise or your biggest surprise kind of as a lesson learned just getting your SPaT deployment operational?
So one of the early things we took notes on was from the Utah DOT's deployment, Blaine's deployment. On one of our pool fund studies that we participate in, some of our folks went out to Utah and heard Blaine talk about how all the challenges he had with interoperability, and they were using multiple vendors and things to get to work. And so we thought we would be smart and say, well, we're just going to use one vendor to do this, and hopefully we'll figure it out with one, and that'll be a lot easier. A lot of the work's already been done. So I was surprised that even with just one, the amount of work that had to be done to get everything talking to one another, that it still boggles my mind how much stuff like related to interoperability we run into even amongst a single vendor's product. So that was very surprising to me.
Yeah. Maud, what was your biggest surprise that you kind of ran into and thinking back about your operational SPaT deployment?
Well, like I said in the beginning, our biggest challenge was with the initial vendor was the technical support and availability of documentation. So when we rebooted and restarted the process of multiple vendors evaluation, we were fortunately we found that the 2 vendors that we selected, CAPS and Lear, without a whole lot of effort, the interoperability existed. The 2 images that I showed you guys, the 2 OBUs were able to receive and interpret the SPaT messages and the map messages from all 20 devices without any complication. So we were happily surprised in that regard that the interoperability existed, and that was part of our evaluation. But again, the technical support is still a big challenge, just because we lack the expertise ourselves to do certain things, and that's going to be a focus for us moving forward to acquire some of those expertise needed to efficiently operate the system.
Yeah, and even from my perspective, going around and talking to other deployers out there, they have noted that the interoperability amongst the vendors have been improving. I would say at least the pace of capability is improving. And Blaine, I wanted to ask you the same question, but you have a bit of you've been able to kind of keep track of a lot of the national deployments. What would you say is the biggest surprise kind of out of all of this?
Well, I think there were a couple of things for us, and we started this about 4 years ago, and Alan mentioned interoperability. That was probably our biggest surprise. We had 4 different vendors of DSRC equipment and 2 different signal controller vendors, and we just sort of assumed going in that all of these would talk to each other and that things were more mature than they were, and they weren't. And we put a lot of work into sort of making those things happen. And every vendor of DSRC equipment dealt with little tiny issues in different sorts of ways. I think luckily a lot has happened particularly in the last year or so, to get over that problem. And as Mo described, he didn't have as much trouble with that. I've talked to some other people who've been deploying who have not had as much trouble with that. Some sites are using the V2I hub that was created by USDOT, and they've had really good success with that. I think the vendors have sort of come around. The hardware has matured. I know that Federal Highways recently hosted an interoperability test with the 3 pilots from Wyoming, Tampa, and New York City, and they brought applications and devices to Virginia, and with some minor tweaking, everything worked pretty well. So I think that has come a long ways. The other challenge that we had that was a surprise, if you look back to some of the very original SPaT challenge documents, sort of the one-page flyers that we put together, there's a quote in there from me that basically says, it's pretty easy to get the SPaT data out of the controller. It's a standard NTCP message. Well, it just wasn't true. Some of what you need to get out of the controller was hard to get at, depending on what kind of controller you were using. So just getting the data and translating it into a SPaT message in the beginning was difficult. Again, the signal controller vendors have worked through that. Some of them now sell devices or coprocessor cards or other kinds of things with their controllers that have made those easier. And so I guess the message from that for people who haven't deployed yet is, before you get too far in, look at your controllers, talk to your controller vendors, and you need to make a decision as to whether your controllers are updated enough to support connected vehicle work in general, and whether part of the cost of your deployment will be upgrading your signal controllers. And some will find they'll need to do that, and some won't. So those were some challenges that we had.
Yeah. One last question for the 3 of you. It's something that's definitely been encouraged, especially from the SPaT Challenge Working Group that develops these resources. They've been coordinating with the OEMs, and through some of our OEM partners, they've been able to give us what we call the SPaT Challenge verification document. If you go to that main page on the website, on the web page for the SPaT Challenge, you'll see that linked. And I wanted to ask, have any of you referenced that document and kind of been able to see if you've been able to validate through that process and what the verification document outlines? Have you been successful, and are you starting that anytime soon? Alan, do you mind if we start with you on this?
Yeah, no problem. We didn't initially reference that document, but when working with Southwest Research, we made sure that that document and the validation they were doing translated from A to B, and that it was covering the same bases, and the same things were being checked. So I guess in a roundabout way, we did use it, but just not directly.
Blaine, I guess I'll ask you, and then Maud, I'll ask you the same. But Blaine, you were pretty critical in bringing that verification document out. Have you had success kind of just applying it and using it for your intersections in Utah?
So that's an interesting question, Patrick. The formation of that document, the origination of that document came when we were together with some automakers and described to them the SPaT challenge, and they were excited about it, thought it was a great thing. They liked to hear that we were deploying stuff on the intersections or on the roadside that they could communicate with. But they looked at us and said, how do we know that the broadcast messages you're sending we can receive? And that started the conversation about how to verify. And what they did was they took a particular application, a red light violation warning application, and basically wrote a CONAPS document, if you will, and said, here's the data that needs to be sent, the SPaT and MAP data elements that need to be sent, here's the frequency, and they wrote up a process of how you would see that, if you will, on the automotive side and verify that you're getting the right data at the right frequency. They also described that in order to really verify your system, you need to make sure that the OBU that's receiving the data in the verification process is of a different brand than the RSU that you're sending the data with, so that you sort of prove the interoperability, because the chance of a vehicle having the same brand of device that your roadside has on it is fairly slim at any given time. So we worked through that, and it's been disseminated, and a lot of people have downloaded it and looked at it. We haven't had anyone come back and say, we've used it specifically, and here are our results. But what we do see is we see deployments like the one Alan described in a variety of places where they're going a step beyond the SPaT challenge and they're outfitting vehicles with something, whether it's just temporarily or permanently. We've outfitted buses, UTA transit buses, and other agencies have outfitted cars for other reasons, fleet vehicles, and they're getting the data into the vehicle from the RSU. So people are verifying it based on its use, and once you've got a system up and running, well, clearly the message is getting there and being used appropriately. Now, in some cases, the OBU and the RSU are of the same brand. In some cases, they may not be, and so there's that question. So we've continued to have the discussion about, is it a real verification if the people who built the receiving end and the people who built the sending end are the same? In other words, we can often make our systems do what we need to make it do, but does that mean a third party who didn't, get inside the box and fiddle with our software and hardware, can they still receive the message? So we're continuing a discussion with the automakers. In fact, we had another detailed discussion with them last week about how all of us who've deployed can use this verification tool and whether there are some kind of incremental steps we can take. We've also looked at a tool that people could buy or borrow, bring into their location, run it up and down their corridor, get data and verify it that way. And so we're looking at that as a tool. So it was a long answer, but I think a lot of people have verified based on their own specific deployments. We haven't had anybody report back and say we've verified and here's how we've done it. So we need to kind of reach out. Maybe somebody on this call has done that, and they could share that with us. We certainly would like to know from those who've downloaded the document how they've used it. I think a lot of us have read through it and looked at it and taken the principles to heart and used it as we've designed our systems, but may not have gone through and actually done the formal verification. We're trying to figure out exactly what formal verification looks like. So long answer, sorry, but that's sort of where that's at.
No problem. It allowed for our very last question that we'll be able to answer on our webinar today to come in. from Vijay Sabawat. Blaine, I think you might be in the best position to answer this question. Is there any study that was conducted to see how the driver behavior is being impacted by providing SPaT data? I think to set this up a little bit more, it's probably a little bit more of the HMI interfaces where we're seeing just some pilot uses. But are you aware of kind of anything further, Blaine, in regards to driver behavior?
I'm aware of some studies in general about driver behavior using onboard data, not necessarily just the SPaT data. I haven't seen any specific results that deal with SPaT data specifically. I mean, in some of our, so first of all, in many SPaT applications, there's no receiving end, right? They're just broadcasting SPaT and map. In applications like ours, the data is coming into the transit bus, and the system on board is making decisions about whether to request signal priority, but it doesn't interface with the driver at all. It's entirely transparent. The driver isn't in the loop, doesn't see what's going on. So there's no driver behavior in that particular case. But there are some people out there studying those kinds of things. I don't know if Alan has any feedback in his work with SPaT data and some of the interface tools he showed. Alan?
Yeah, nothing official. Anecdotally, I can say that all of our users that have used it drive differently and a lot less aggressive. But that's certainly not a conclusive study in driver behavior by any stretch. But yeah, nothing official that I know of.
So Patrick, I can't put my finger on it, and this is again a little more general than SPaT data, but we've looked at some studies that have been done that indicate that if the driver gets a message, and it could be from a VMS sign or it could be internally, if a driver gets a message and perceives that that message is specifically for them, not just a general message for all travelers, but applies specifically to them, they're more likely to act upon it. And I can't put my finger right on that study, but we've looked at that as we've talked about other V2I applications and where we might use them, that there is some driver behavior in that way.
Yeah, and on that note, I think it just shows that this area really is expanding into what I would say is a little bit of a new frontier for our industry, and just the ability to be able to see if we can get personalized or individualized messages to drivers and what their reactions are. But for any of you that are on the call that are in the research field on this, that's another great area for you to contribute to our practice. And so with that, I want to thank everyone for attending today's webinar. I really want to thank our panelists who had really good information and knowledge that's being shared, at least with these SPaT deployments, and making them operational and getting them beyond just one or two intersections. And you see that each one of these sites are actually looking beyond just kind of their initial 20. And so a recorded version of this webinar, along with the presentation slides, will be available on our website in about 24 to 48 hours. And on behalf of the National Operations Center of Excellence and our presenters, we want to thank you again for joining us today, and have a wonderful rest of the day. Thank you, everyone. Bye-bye.